Okay, so we've been talking about the integral, the definite integral, and area under the curve. Okay, so today we're going to be talking about the definite integral kind of as area. Okay, so by now we've talked about this definite integral. Okay, so this is the definite integral itself. Okay, and when we think about what it represents, the f of x represents the height of any one rectangle, while the dx represents the width of a rectangle. So basically what we're dealing with is we've been talking about rectangular approximation. And in this case, the function height tells us the height of our rectangles. Dx is that change in width. So the area of any one is f of x dx. The integral part, this part, is basically the summation of them. And it's summing up the infinite amount from point A to point B. Okay? So that's what we're dealing with here. Okay? Now, when A is less than B, we are determining the area under the curve from left to right. In that case, our dx is a positive number. Okay? And if the function is above the x-axis, then it will be a positive number. So any area above the x-axis, in between the function and the x-axis, is positive. Any area below the x-axis we consider negative. Also, if b is less than a, which means that b is smaller than a, then our dx is going to be negative, which means our integral will also be the opposite sign, negative. Okay? So, we'll talk about that more in just a minute. Okay? But basically, these are some rules that we need to know. Okay? Rule number one. This is one of those duh moments. Okay? If we're dealing with the integral from a to a, remember, we're talking about area. If we're talking about the area that starts at a and ends at a, we're talking about no area. So that's automatically 0. Okay? Now, we just talked about this. If our integral from a to b, if we switch our starting point and our ending point, if we reverse our limits, we actually are changing the sign. So if you reverse your limits, it makes it negative, or changing the sign. So if it was originally positive, it becomes negative. If it was originally negative, it becomes positive. Okay? And number 3 is another one of those duh rules. It's almost, why do you even say it? But if you take this area from A to B, okay, from A to B, and then you add the area from B to C, then that's the same thing as the area from A all the way to C. Wow. Amazing. Okay, that's actually almost like the law of syllogism that you learned in geometry. Those if-then statements, if A then B, if B then C, therefore if A then C. Yeah. Basically, that's the application of it. Okay? So let's do some basic practice using these definitions. Okay? So right here, this is our f of x graph. Okay? It's formed by some lines and one semicircle. Okay? Find the definite integrals that they give us. So, number 1, they're asking us to find the area under the curve from 4 to 4. Well, that goes back to what we just talked about. And if our area starts at 4, so look, this is 1, 2, 3, 4. If it starts here and ends here, there is 0 area we're talking about. Okay? Now, the area from 0 to 1. So here is 0, here is 1. So we're talking about this area right here. Well, what kind of shape is that? That's a rectangle. How do you find the area of a rectangle? Well, this is 1, the height is 2, so this area is 2. So basically what we're doing here is we're finding area based on these geometric shapes. Okay? All right, let's look at the next one. Number 3, my area is from 1 to 3. Okay, so here's 1, here is 3. So we're talking about this area right here, this triangular area. So what is this area? Well, the area of a triangle is 1/2 base times the height. The base is 2, the height is 2. So this area right here is 2. So this is 2. I'm going to write this in red, 2. Okay? So therefore, let's look at number 4. This is where it gets really difficult. Now what's the area from 0 to 3? Now we're starting from this point here at 0 and going all the way to 3. Well, it means all of this area. Well, we know this area from 0 to 1 is 2, and then from 1 to 3 is 2, so the total area from 0 to 3 is 4. There you go. Good job, guys. So you see, this is actually really, really simple, okay? The hardest part is when you start dealing with some of these rules. So let's look at number 5. So we're finding this area, okay? It says area from 3 to 6. So here's 3, 4, 5, 6. Okay? So we're talking about this area right here. Again, this is a triangle, right? So base is 1, 2, 3. The height is 1. So 1/2, that's 3/2. Okay? So that's the area. But the integral that we're dealing with says that since it's underneath, the area is -3/2. Okay, so area above the x-axis is positive, where the area underneath is negative. Okay, but look at number 6. Number 6 says, what is the area from 6 to 3? So basically it's the same area from 3 to 6, but we've now reversed our limits, which means this is the same thing as 3 to 6, but negative f of t dt, which means that this is, in fact, positive 3/2. So when we start adding these rules in, if you don't know the rules, it gets a little bit more difficult. Okay? All right. Let's look at... Oh, that's too far in. Let's look at from 0 to 10. Let's skip to number 10. Okay? From 0 to 10. So here is 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10. So I want someone to know what this total area is. Okay? So we already know the area from 0 to 3, which is 4. We know the area from 3 to 6, which is -3/2. Now we need to figure out what is the area from 6 to 10. Well, this is a semicircle with a radius of 2. So 1/2 pi r squared. So that means that our area is going to be, so this is going to be pi times 4/2, which is 2 pi. So this area is 2 pi. So when we add them all together, that means it's going to be 4 minus 3/2 plus 2 pi, which ends up being 2.5 plus 2 pi. Okay? And number 11, of course, is the same thing but negative. Negative 2.5 plus 2 pi. Okay? So you can see how these get not more difficult, but your understanding level needs to go up. Okay? Now let's go look at number 18. Okay? And this is where it gets a little trickier. So number 18, it says the absolute value of the integral from 0 to 10 f of t dt. Okay? So order of operations says that we've got to do what's inside the absolute value first. So basically, we're taking what we found in number 10 and then taking the absolute value of it. So this is the absolute value of 2.5 plus 2 pi. Okay? Which is still just 2.5 plus 2 pi. Now, that's different than number 19. Okay? Because number 19 is saying we're finding the area of the absolute value of the function. Okay? Which means before we find the area, we take anything that was negative. So in this case, this part right here, we have to take the absolute value of it first. So this becomes positive. So this, number 19, is basically going to be the 4 plus 3 halves plus 2 pi. All of those areas, but them being positive. Okay, so that's where it gets a little tricky. Okay? Number 21 is the other one that we want to look at on here. Okay? So, basically, this is telling you that you want to find the area from 10 to negative 4. Okay? So, first of all, you're going backwards. So, to help us a little bit, we're going to do this from, change it to negative, of negative 4 to 10. The absolute value of 2 f of t dt. So we've got multiple steps on this one. So first of all, we need to find all of the areas. So here's negative 1, negative 2, negative 3, negative 4. So this area right here is negative 1/2. Okay? This area here, I'm going to break this up into pieces to help myself out here. So base is 1/2. The height is 1, 2, 3, 4, 5, 6. 6 times 1 divided by 2. This area is 3. This base is 2. 1, 2, 3, 4. So 4 times 2 is 8 divided by 2 is 4. And this is 4 here. Okay? So we have to find the total area of all of these things. So that's what we just did. So from negative 4 to negative 3 is negative 1/2. From negative 3 to negative 2 is 3. From negative 2 to 0 is a total of 8. Okay? Now, it says 2 times these numbers. So basically, to do this one, we've got to take each area, we've got to multiply it by 2. So negative 1/2 times 2 is negative 1. So this is negative 1. And this is going to be 6. And 8 times 2 is 16. And this is 4 times 2 is 8. Negative 3/2 times 2 is negative 3. And 2 pi times 2 is 4 pi. So those are our areas multiplied by 2. But it also says to take the absolute value of them. So all of the negative ones will become positive. So we go add these up. So it's 1 plus 6 is 7. Plus 16 is 23. Plus 8, 31. Plus 3, 34. So 34 plus 4 pi. So this is negative 34 plus 4 pi. And that's our answer. Okay? So you can see where this kind of gets a little bit difficult just because of what we're trying to find. It's multiple steps. Okay? Order of operations makes it more difficult. But relatively still easy. We're just dealing with areas. And I'll do one of these problems in my next video.